Okay, so this is lecture 3.4 for class. I know that you guys had my math lab lectures, but this is to add on to do some examples that we would normally do in class. So let's dig in. We're just going to kind of pick this apart and take it slow. So 3.4, our learning objectives are to determine the converse, inverse, and contrapositives of a conditional statement. And if you remember correctly, a conditional statement is an if-then statement that usually looks like P arrow Q, which is read P implies Q, or if P, then Q. Remember that the P is the antecedent and Q is the consequence. We've also called the P the hypothesis and Q the conclusion. In this video, I will be calling it the antecedent for P and the consequent for Q, because it'll be a little bit easier to follow. Remember that these are conditions. P is a condition. And when we do a truth table, we're seeing if the condition is upheld by the conclusion or the consequence. If the conclusion happens and the consequence does not, so that means you have a true for the condition, or P for P, and you have a false for the conclusion, meaning it didn't happen, the entire statement becomes false because it's a lie. We talked about the idea of if I eat my dinner, then I get a cookie or I get a dessert. I'm just putting cookie. I get a cookie. If you eat dinner and your parents don't give you a cookie, they lie to you. So remember that. So let's say it's true you ate your dinner, but it's false that you got a cookie, then it's false and we're looking for the lie, and that is the lie. All right, so let's dig in. The other things we're going to do here is also translate conditional statements into alternative forms. There are so many different forms you can do this. We're going to recognize a structure of a biconditional, and a biconditional looks like that if and only this, if and only is a biconditional, and we're going to summarize truth tables of compound statements. So first of all, let's look at this. Let's examine the conditional statement P then Q. It says if P then Q. The converse of that is where you take Q and switch it up with P, and you get if Q then P. That is called the converse. Now you can take this a little bit further, and you can take what they call the inverse of if then, and that says that you negate both the antecedent Q and the conclusion or the consequence P, and it's not P implies not Q, or if not P, then not Q. So that's the inverse. The contrapositive says that you're going to flip them first and then negate them. So it becomes if not Q, then not P. So that's what the contrapositive says. And that's this guy right here. One thing you want to notice, and I have a typo here, is, that should not be in, is that the inverse, notice that the inverse, I am making typos right and left here, everyone. Give me a second. Notice that the inverse is the contrapositive of the converse. So that's basically saying that here's the inverse right here. And that guy, you took it and you flipped it and negated both of them. And that means that it's the contrapositive right here. So the contrapositive means that you flipped them. So you got not Q, then not P. And then you negated these to become not Q implies not P. These suckers go away, and you got P then Q. So that's all that's saying, is that these are contrapositives of each other. And it was a weird statement. And it even has that in the book. So I wanted to clear that up for you all. All right, so they're contrapositives. One thing we want to do is, one objective that you're going to be asked to do in the homework and on your tests and quizzes is you're going to take these ideas from here and you're going to determine related conditional statements. So, for example, if we have this statement right here, we want to determine each of the following given the conditional statement. If I am running, then I am moving. For all of these, we can first let P equal the first statement, I am running. For Q, we can let that equal I am moving. So Q will equal I am moving. That's your very first step. Identify your P and Qs for any type of statements like this. Now, we want to determine each of the following given the conditional statement. Now, they're going to ask you to do this in my math lab, and it is very as simple as it looks. All right, so the converse, so this is an if-then statement. So we have right here, if I'm running, then I'm moving. And we can first start with it. P implies Q. And if we want to find the converse, well, we look up here and it says, oh, the converse is where we just flipped the Q and the P. So we put Q right here and the P, and here is the converse. However, we have to substitute the words back in. So that's our third step, to sub the words back in to get the end statement. So this becomes, if Q is first and Q is I am moving, right here, we say if I am moving, because we have to put the if, then hit pause and see if you can tell me what comes after that. If you said I am running, that would be a correct statement. So that's the converse. This is the Q term right here. This is Q, and this is P, and you just flipped them. So this would be your final answer, and they will ask you to do that on my math lab. If we want to find B, well, let's do a different color here. We want to find the inverse. Well, the inverse of if P then Q, or P implies Q, is, well, if you look up here, it says you have to negate them both. So we negate the P. So this becomes not P implies not Q. And then we obviously negated the Q. So then we would take the if-then statement, P implies Q, apply our inverse rule, which is just to negate the P, then Q. And this one's going to be a little trickier because we have to sub the words back into here. But we have to negate P to do that. So P says I am running. So the negation of P would equal I am not running. The not negating it, making it false. The negation of Q is I am not moving. And then you would have to take these two sentences, since P comes first, put it between the if and then. So it would be if I am not running, then I am not moving. Now, in all these sentences, I want to really point out that some of these are not necessarily true. So just be very, very careful with these and do if-then or your truth tables to see if they make a sound logical judgment. They're not necessarily true. Okay, so one thing I want to point out here, and I want you to hit pause here, and we're going to look at these equivalences of these conditional statements and their contrapositives, all right? In a conditional statement, its contrapositives, its conditional statement and its contrapositive are equivalent. That means they have the same final result on the truth table. Also with these, the converse and the inverse are equivalent. So what we're going to do here is we're going to create a big truth table that demonstrates this with our, well, we're not going to have pick partners. We're not going to do it out loud in the chat box or anything like that. We're just going to do it over this video. So remember, these notes were created whenever we used to meet in person. All right, so if we want to create a big truth table using our contrapositives, so up here we know that we have first our regular sentence, P then implies Q. Then we have its converse, which is P, Q then P, because it just flips. And then we have its inverse, which is just negating the P implies Q. So this becomes not P implies not Q. So that's the inverse. And then the last thing, what is the last thing? What do we do? If you said out loud, we go to flip Q, negate it, and then negate the P to make it contrapositive. Basically, we flip the P and the Q and then negate them, and we have the contrapositive, then you would be correct. I'm trying to make this video as hands-on and engaged as possible. All right, so how to do these true statements is that since we have nots here in each one of them, I would do the not P's first, the not P and the not Q. Next up, I would start with the P then Q, because what we're doing is we are showing that these truth tables are equivalent. So we want to make sure that we start with the original statement so we can see what the end results are. And then we're going to start, so this is the if-then statement original, the OG. And then we're going to do the converse. You could have done it any way you wanted to. So this is Q implies P. Then we're going to do the inverse. Not P implies not Q. And then we're going to do the contrapositive. And this is the not Q implies not P. So I'm going to start with all my cases like I usually do over here. Like we've been doing in class, TT, TF. And then I'm going to say, okay, I know this is false, false over here. This is false, true. This is true, false. This is true, true. Because remember, negation takes it from true to false and then false to true.